Let's take a look at the next set of examples in 6.2. Here they ask us to use either a normal distribution or a t-distribution to construct a 90% confidence interval for the population mean and to justify our decision. In other words, make sure we're able to explain why you would use either the ZC or the TC. They also say that if neither distribution can be used, explain why. In example 5, suppose we have hospital wait times in which we have a random sample of 19 patients at a hospital's minor emergency department. They tell us that the mean waiting time before seeing a medical professional was 23 minutes and the standard deviation was 11 minutes. They say assume that the waiting times are not normally distributed. Well, the answer to this one is we can't do it, at least not with the methods that we're going to discuss in our class. There are some more advanced statistical calculations out there that can be done, but if you go back to kind of like the very beginning of this test, of this section. So remember, we either needed a large sample size, or we needed that sigma was what? Known, and the population was normally distributed. Here we don't have that. We have a small sample size. So in order to use either one of the two things that would follow, we would need to know that the population was normally distributed, and we don't have that. So this one is one that cannot be solved. Let's take a look at the next one. This is a problem where they actually give us some raw data to work with. In a recent season, the standard deviation of the yards per carry for all running backs was 1.34. When they say the standard deviation for all, that means that that's a population standard deviation. So this would be the value for sigma. Sigma equals 1.34. The yards per carry of 20 randomly selected running backs are listed below. So we have a sample of size 20. Furthermore, this is the data from each one of those 20 running backs in terms of yards per carry. Assume the yards per carry are normally distributed, which is key. We're going to need that. We want to calculate for this one, we're doing the same as the previous problem. We're going to do a 90% confidence interval. Well, our sample size is small. We do have less than 30, so we got to be a little bit careful here. We do know it's normally distributed. And furthermore, because we know sigma, that means we will be able to do a z interval on this one. So first thing we would want to do, we can enter all of these values into the calculator to help us find the sample mean. I would go to my stat menu, edit, simply put these 20 values all in one list. I would recommend putting them under list L1. And then you can do stat, go over to calculate one variable stat, and we would see that the sample mean for these 20 values would be 4.3. So x bar is 4.3. The only other thing we would need for our confidence interval is the margin of error. And the formula for that margin of error again is E equals ZC times sigma divided by the square root of n. We know from the problem that sigma is 1.34. We have a sample of size 20, so it's going to be divided by the square root of 20. We would just need to find the z-score that corresponds to the 90% confidence interval. We would go second distribution, inverse norm. For 90%, the area would be 1 minus 0.90 divided by 2. That's going to be 0.05. 0, 1, because we're looking for a z-score, so it's standard normal. Go ahead and hit enter. And we would see that the z-score to 3 places is going to be a positive 1.645. So positive 1.645 for our critical score. We can go ahead and plug that into our margin of error. We get 0.49. And now we're ready to construct our confidence interval. The confidence interval will go from x bar minus e to x bar plus e. That is 4.3 minus 0.49 to 4.3 plus 0.49. This would give us the following interval. And the conclusion to this would be that we can claim at the 90% level of confidence that we believe that the true yards per carry for all running backs in the league would fall somewhere between 3.81 and 4.79 yards per carry. The other way we could have worked this problem more directly using the command in the calculator is if we have our data entered under the stat menu. So if I have all of these 20 values listed under L1, I can simply do stat, go over to tests, and we can construct the z-interval by working off of the data tab. So instead of having highlighted as stats as we've done for the last few examples, I want to highlight the data tab and hit enter. What they need to know from us is what was the standard deviation of the population. That was 1.34. Our data we stored in list L1. The frequency should always be 1 for every case where you're working with this. And then they wanted to know the confidence level, which is going to be 0.90. We can go ahead and hit calculate. And that too would have told us that the z-interval for the 90% confidence level would be 3.81 to 4.79. Let's take a look at one more example. In a random sample of 50 people, the mean body mass index, or the BMI, was 27.7, and the standard deviation was 6.12. Assume that the BMIs are normally distributed. So we know we have a normally distributed set, and our sample is 50, which is more than 30. So to construct the 90% confidence interval for this will once again allow us to use a z-score. For this problem, I'm just going to use the z-interval command. I'm going to go to stat, test, go down to z-interval. Once I recognize that that's the appropriate interval to be using. This time, we weren't given the BMIs of all 50 individuals. We just have the summary statistics. So I want to work off of the stats ribbon. I'm going to move over to select stats and hit enter. The standard deviation was 6.12. The sample mean, they told it to us, was 27.7. Sample size of 50, and we're sticking with the 90% confidence interval. If we go ahead and hit enter to 2 decimal places, this would give us a lower bound of 26.28 and an upper bound of 29.12. So our conclusion, the interpretation of this would be that we are 90% confident that the true mean body mass index for these individuals would be somewhere between 26.28 and 29.12.